Hello, and welcome to this webinar being presented by LJ Star. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenters. With us today, we have Chrissy Brunn and Christine Michael. Both work in inside sales and technical support for LJ Star. To read more about our presenters, please look at the Speaker Bio window right next to the main presentation window. And Chrissy and Christine, welcome to today's event. And with that, I will pass things along to you to get started.
Thank you, Matt, and hello, everyone. My name is Christine Michael. I'm an expert here at LJ Star for the industrial sight glass market.
And my name's Chrissy Brunn. I'm an expert with LJ Star for sanitary sight glasses used in pharmaceutical and other sanitary applications. This webinar, Getting the Most Out of Your Sight Glasses, will cover the following information: overcoming common challenges in operation, how to select the right sight glass for an application, and best practices for inspection, maintenance, and installation.
Why does it matter? Because understanding your sight glass, how they're constructed, the best maintenance practices, and how your peers solve their challenges will enable you to avoid further failures and extend the service life and performance of your sight glass, and keep your workers safe. To get oriented, let's do a quick review of equipment and industries that this webinar covers. There are many types of sight glasses, depending on the application. Chrissy, how are sight glasses used for process observation?
Despite the trend toward automation, there is still a need for a human to observe a process in many applications. A sight glass window on a reactor lets a technician observe color, foam, and other characteristics vital to understanding a process. Also, they allow technicians to verify clean-in-place procedures were completed and that there is no residual cleaning solution. From beer to penicillin, these applications need sight glasses for observation and lights to illuminate the vessel interior.
Process observation is also important in non-sanitary industrial applications, such as those dealing with chemicals. Operators want to see the process going on inside the tank. Industrial sight glasses are usually part of the sight glass window assembly, bolting onto an ANSI phalange or welding onto the metal vessel.
Sanitary sight glasses are constructed of a glass disc fused to a metal ring. They're attached to a vessel using a ferrule with a tri-clamp or sanitary clamp connection, so the sight glasses can be quickly removed for cleaning. Christine, what other types of sight glasses are there?
A different way to use sight glasses on a tank is for product level indication. Another application is visual sight flow observation. Installed on a process pipeline, a visual flow indicator gives the operator a fail-safe way to see if the process fluid or gas vapor is flowing. However, this presentation will focus more on industrial and sanitary sight glasses. Types of sight glasses. For process observation, there are two types of sight glasses. Sight glass assemblies have a glass disc, that is sandwiched between two gaskets held in place by a cover flange. The flange is bolted onto the process vessel. Sight glass windows have glass that is fused to a metal frame the metal frame is usually clamped onto the process vessel. Sight glass windows offer high pressure ratings and can be reused after maintenance is performed.
Because we work closely with so many customers, we have many stories about operational challenges and how to solve them. We're sharing them with you in the hope that they will help you solve or avoid your own issues.
I recently quoted a customer who needed a knob round for a seawater deionized water application. I quoted a variety of sizes, all with FEP shields. The FEP shield is held by clamping on in between the components. There is no adhesive. I also provided the FEP shield data sheet that explains how it helps protect the tempered borosilicate glass over time. We use FEP shields or mica shields during times when a customer has a liquid product that is non-adhesive. It prevents it from etching.
Oftentimes, condensation can be an issue as you try to observe your process. One specific customer who I work with comes to mind. To clear their condensation issues, they have now standardized on our weld-type DIN 28120 sight port with a spray unit and wiper assembly. Bye-bye condensation. How about illumination and cameras? Any good stories there?
Actually, I do. One of our local distributors handles all of the paint manufacturer's facilities. I quoted a couple 6-inch bolt-on units with EX-proof LED lights and a couple 4-inch bolt-ons with EX-proof colored cameras to be used on cooling tanks and reactors to ensure the proper chemical reactions occur during manufacturing. The lighting also allowed the manufacturer to observe the color changes to meet manufacturing requirements.
That's great. For safety reasons, we also have many customers who've changed out their standard sight windows and use METAGLAS fused sight glasses instead. What are the ways sight glasses can fail?
Sight glasses can fail in multiple modes. They can become cloudy, obscuring vision. They can crack and even leak, putting a batch of costly media at risk of being scrapped. In pressurized applications, they can fail catastrophically, which, although rare, has been known to injure or even kill workers. What are the factors that contribute to sight glass failures?
The first factor would be improper design. Let's review. A cover flange that is too thin permits a bending load on the glass during bolt tightening. This may go undetected because the cover flange can hide the cracks in the glass. Also, too few bolts will create point loads on the glass from uneven compression, which may cause cracking as well. Cushion gaskets are an important part of the design as well. A cushion gasket that's too soft or too thick is a problem. It doesn't provide proper support and can put a bending load and tensile stress on the surface of the glass.
The last design issue is inadequate glass thickness. Incorrect coefficient, improper formula, or miscalculated unsupported glass diameter. The internal pressure may exceed maximum pressure capability.
Going beyond design issues, improper installation, mishandling, and poor maintenance are all possible causes of sight glass failure. Improper installation, over-tightening, and uneven torquing of the bolts is a good example. Checking the sealing surface is also important. Gaskets can become baked onto the flanges and must be removed when the glass is replaced. Trapped debris can pit, scratch, or bend the glass, causing a failure. As far as mishandling is concerned, using the sight port as a handy place to rest a wrench is never a good idea. Impact from an object creates pitting that makes a stress concentration point, which can cause failure. This is comparable to making a tiny cut or tear on a piece of paper and then pulling on it. In fact, the same thing is done when glass is cut. A glass cutter scores the glass, creating a small depression in the surface, and then a bending moment breaks the glass along the scratch surface. This is like a sight glass with a surface scratch and pressure behind it, creating a bending moment. Poor maintenance is also a big issue. We never advise to reuse conventional glass discs or gaskets. When replacing one, it's safest to replace them all. Compressing the glass between two flanges will create scratches and pit the glass, so don't forget to use your seal and cushion gaskets. Scratches, even those too small to see, create stress concentration points, making it important to have a regular maintenance schedule. Be proactive, not reactive. Those are the maintenance issues. What are some of the operational causes of sight glass failure, Christine?
For starters, there is thermal shock. A sudden change in temperature can cause one surface of the sight glass to contract or expand too quickly. For example, cold water washdown of a hot sight glass, hot startup of a cold sight glass, or heat from a high wattage light on a sight glass over a cold process. Also, there is overpressurization. A calculation or an unexpected increase in system pressure could exceed the design pressure of the sight glass. Degradation of the sight glass. In chemical corrosion, there is a measurable loss of glass weight when it is exposed to certain chemicals. With erosion, it can be degraded from abrasive process media.
The biggest mistake that people can make with sight glasses is specifying the wrong type of sight glass for their application. Your sight glass supplier will need to know important points of information about the application. Mainly, their pressure, temperature, and mounting or connection type. Based on those specific application details, we can determine the appropriate sight glass for your application. Of those three, we wanted to cover pressure a little bit more since pressure determines the thickness of the glass. In determining sight glass thickness, the formula shown is used. This formula takes into consideration the unsupported diameter, the operating pressure, and allowable stress. The allowable stress of commonly used glass is as follows. Tempered borosilicate 3000 psi, annealed borosilicate at 1000 psi, quartz at 750 psi, and tempered soda lime at 2100 psi. Choosing the wrong glass may have serious implications, so let's compare the characteristics of the two most commonly used, soda lime glass versus borosilicate glass. Soda lime is common glass and makes up 80% of all glass manufactured. Think window glass. Borosilicate glass is a different formula that adds boron and removes lime. One trade name of borosilicate glass that you're probably familiar with is Pyrex. Borosilicate is the best type of glass suited for use in most chemical and pharmaceutical applications. Select your type of glass based on your specific applications, temperature, pressure, and chemical resistance requirements. Let's talk about temperatures here. Soda lime is suitable for applications up to about 302 degrees Fahrenheit. Borosilicate handles operating temperatures up to 536 degrees Fahrenheit. High process temperatures require quartz or sapphire. These materials are not glass and they are more expensive. Acrylic lenses are suitable for lower process temperatures up to about 225 degrees Fahrenheit. Acrylic is used in applications where companies want to avoid the risk of broken glass ending up in the process media. A few examples would be cosmetics or food and beverage. Let's also look at the pressure and temperature comparison of borosilicate versus soda lime. Pressure is related to temperature because the pressure rating for a sight glass decreases as the temperature increases. Soda lime glass has a low maximum working pressure compared to borosilicate glass. Chemical resistance. Glass is a chemical compound. Over time, it will react with process media, even water. Borosilicate glass is more resistant to chemical attack than soda lime. For extremely acidic or caustic applications, such as sodium hydroxide, hot concentrated alkaline solutions, phosphoric acid, or fluorine, a shield of mica or FEP may be required. Soda lime glass has less chemical resistance. Generally, it's not recommended for chemical, biotech, and pharmaceutical processing applications. There are concerns that soda lime glass may leach into the process media. Soda lime glass does not meet USP Type 1 standard, which is required for non-parenteral injectables pharmaceutical applications. Methods of strengthening glass. Heat-tempered glass. This is where glass is heated, then cooled with a steady high-pressure flow of compressed air. This quickly cools the surfaces, which go into compression, while the core, or inside, is allowed to cool more slowly and goes into tension. Heat-tempered glass is 3 to 5 times stronger. Fully tempered glass has surface compression of 10,000 psi. But, Christine, what if your application needs an even stronger sight glass?
Mechanically compressed glass. Heat tempering is not the only way to toughen glass. Glass can be strengthened by placing it in mechanical compression. Like concrete, glass is strong in compression, but breaks easily under tension. During manufacturing, the glass is heated inside a metal ring. The ring expands because of the heat. As they cool, the glass hardens before the metal can shrink back to its original size. This places the glass in radial compression. Radial compression offsets the effects of tensile stress. There are almost no process conditions under which external tensile stress would overcome compressive stress. Under such strong compressive forces, the glass becomes elastic. Therefore, sight glass windows have a higher pressure capability than sight glass assemblies. Taken to the extreme, a sight glass window will not shatter. When the surface stretches beyond the elastic capability, small cracks may develop near the surface. The subsurface glass is still under compression and can remain in service safely for a short time.
Glass-metal combinations. The highest performance sight glass windows are made of borosilicate glass and duplex stainless steel rings. The differing coefficients of thermal expansion in these two materials create a superior level of radial compression, but not so much compression that the glass breaks. Hastelloy, Monel, and Inconel stainless steels are also used in sight glass windows for their chemical resistant properties. These generate less radial compression and therefore offer slightly lower pressure ratings. You can view these details on the screen now.
One last selection tip: standards and documentation. When you buy a sight glass, ask the supplier to supply documentation that meets all applicable standards for performance and safety. You might be surprised how many suppliers cannot back up their claims. For example, including factory mutual, sight glass fused to metal to DIN 7079, borosilicate glass to DIN 7080, USP Class 6 and BPE compliant, USP Type 1, borosilicate, TÜV certified, PED certified, Quality Assurance System CE 0035, certified according to EAC regulation.
We have covered all the considerations of sight glass selection, but what about the day-to-day work that preserves your investment?
Like other process equipment, sight glasses must be maintained properly to maximize their life and your return on investment. Also, in applications involving high pressure and high temperature, the proper care and inspection of sight glasses are critical to workers' safety. When glass under pressure fails catastrophically, shards travel at ballistic speeds.
Here's how to keep your sight glasses clean. Use commercial glass cleaners. Never use wire brushes, metal scrapers, or harsh abrasives. Do not attempt to clean the glass while equipment is in operation. How to inspect a sight glass. Sight glasses should be regularly inspected for damage. Here's how to inspect a sight glass. To examine for scratches, shine a very bright concentrated light source at an angle of about 45 degrees. Anything that glistens should be inspected closely. Scratches that catch the fingernail or any star or crescent-shaped marks that glisten are cause for replacement. Sight glasses that appear cloudy or roughened after cleaning should be replaced. Also, inspect sight glass frames and flanges for corrosion buildup or gasket material that is baked on. Never reuse glass or gaskets. Once a conventional sight glass has been removed from its mounting, substitute a new glass disc and gaskets. There is an exception. Sight glass windows which are fused to a metal ring may be reinstalled. This is because the metal ring takes the stress of the mounting rather than the glass.
Installation. Know how to install your sight glass properly to avoid damaging the glass, leaks, and unsafe conditions. Never use glass that is scratched, chipped, or otherwise damaged. Glass seating surface must be flat within 0.005 inches with a smooth finish. Flanges must be rigid. Do not allow the glass to contact metal when assembling. Gaskets must be new, clean, and smooth. Use gaskets of the same diameter. Bolting. For industrial sight glasses that are bolted to the vessel, the pressure applied by the bolts should be even to prevent damage to the glass disc. Follow a regular tightening sequence to ensure even loading of glass. Allow a maximum difference of 1.5 foot-pounds between bolts during tightening. Tighten only enough to produce a positive seal against the process pressure. Bolts may be tightened after initial cycling of vessel. Never tighten bolts while the sight glass is hot, and never tighten bolts on a sight glass while the equipment is in operation. And that concludes our presentation. We wanted to leave plenty of time for questions since every application is different. Matt, what's our first question?
Thanks, guys, for that great presentation. And now, yes, we do have some questions, so we're going to move into the Q&A session now. To the audience, if you haven't submitted your question yet, you can still do so now by entering it in the Q&A box and clicking Submit. We're going to try to answer as many questions as we can during today's session. However, if we don't get to your question for whatever reason, we will reach out after the webinar, so please send us your questions. Okay, now for the first question from our audience. We currently use a halogen light. Should we switch to an LED? Guys?
Okay, I'll answer that one. Well, we currently can still supply halogen units. However, we do recommend to most customers that they should consider the LED version. Halogen bulbs are being phased out, and some have actually already been discontinued. So we've actually transitioned most of our units over to the LED version due to the regulations that have taken place around the world. And this shortage of the LED bulbs is forcing companies pretty much to move forward with going to the new LED technology. So a couple reasons: bulbs are being phased out, everybody's moving to the LED, it lasts longer, it's more efficient. Definitely lasts longer. You don't have to change the bulbs for a long time.
That's great. Thank you so much for that. And thank you to the audience member that sent that in. That was a great question. Okay, and we're going to keep on going. We have some more questions here, so let's see what's next. Okay, here's our next question from the audience. Can you explain the benefits of a fused glass?
Yeah, sure, Matt. That's a great question. Also my favorite product. Fused glass offers the ability of seeing in your process while eliminating the possibility of catastrophic failure. Mainly that means that this fused glass sight glass will not shatter into your process. Fused glass sight windows offer higher pressure ratings than a standard sight glass, and they also can be reused after your routine maintenance is performed because, as we discussed during the presentation, it is a metal ring that you would be clamping down, and it's okay to reuse that.
Excellent, thank you for that. And to the audience, we have some great questions here, so just give us a moment to try to manage these. And if you are thinking of any additional questions, you can still send them to us by entering them in the Q&A box and clicking submit. And while you're thinking of those questions, I'd like to also point out on your screen in the top right corner, there's some additional information. We have a copy of the slides you can download, and of course the LJ Star website to follow up with the team. Okay, let's see what's next. Okay, back to the questions. Here's our next question from the audience. What are some of the different ways to light my sight glass?
Good question. We can light your sight glass we have non-EX or explosion-proof lighting that can connect via METACLAMP or bracket. One of our more popular ones is our LumiStar LED non-explosion-proof light. It's very highly desired. Comes in a 24 or a 120 watt, and it can come with or without a mechanical switch. One of our bigger sellers, I would say. We also offer other light and sight combos, such as our LumiStar, which is more like a half-moon shaped lighting option. It allows the port to be used both for the sight and the light, which is very nice. We also have, when somebody has very limited real estate or surface to have both a light and sight area, we have options such as a fiber optic light that has just a small pinpoint, and a lot of the viewing area is mainly for sight. So it has a small light that has a little area that it takes up. We also have the METACLAMP LED ring, which is very powerful yet compact for sanitary processing equipment.
Oh, very cool stuff. Thank you for that. And thank you to the audience member that sent that in. We're going to keep on going with the questions here, but again, to the audience, please send us your questions if you still have some. Now may be your last opportunity to do so. Okay, here's our next question. What are some of the major wear factors on a sight glass?
All right, great question. Certainly not having a routine maintenance plan in place is one major factor. Also, not verifying the chemical compatibility can cause wear issues on both the glass and gaskets and cause issues with your sight glass. It's very important to always confirm this detail on any and all components that come in contact with your process.
Excellent, thank you for that. And moving along to the next question. How can cleaning of our vessel affect the sight glass?
That's a good one too. I'll go ahead and kind of expand on the last one. Oftentimes we use caustics as part of our CIP or SIP process to clean the vessels. These chemicals are sometimes overlooked because it's not the primary media that is within the vessel. You should always check with the chemical compatibility for the CIP and SIP caustics that are used for cleaning and anything else that's going to come in contact with your sight glass. Also the gasket as well.
Excellent, thank you for that. And to the audience, looks like we have one or two more questions in the queue, but if you have anything remaining, please send them in. Or if you have any comments for the team, we'd love to hear from you. Okay, and here's our next question. What should I look for around my sight glass during maintenance that might help me extend the life of the glass?
I'll take that one. Like Chrissy had said, some of the just regular routine maintenance, the sight glass should be definitely looked at on a regular basis for inspections, looking for scratches, cloudiness, etching, or any other physical damage to the actual sight glass. A damaged window can cause a weak point and makes it very susceptible to breaking. So looking at the window on a regular basis will definitely help. You also want to check the gaskets for leakage. Of course, if there's any leaking, the gasket should be replaced or the unit should be removed from the service immediately to prevent any further harm from anything. Evidence of internal or external corrosion is an indication that improper material might be used. We try to catch, of course, everything up front with everybody's application, asking the correct questions and directing them in the correct, steering them in the right direction, but they still also do need to do their due diligence and go to their engineering department and make sure everything is compatible with what we are thinking also. So it takes a team effort, but it always works out.
That's great. Sounds like a partnership is the key. Very good.
Yeah.
All right, let's see. Okay, looks like we have one last question in the queue. So to the audience, now I really mean it. Now is your last chance. So we're going to try to get through this question here, but if we have anything else come in, we'll try to answer that. If we don't, for whatever reason, we will respond after the webinar. All right, here's our next question, possibly the last. Does acrylic materials increase the risk of loss of containment during a fire?
I guess it kind of depends on the situation that we're referring to here. But because acrylic is only good up to 225 degrees Fahrenheit, I would assume that it would be one of the first components to melt if there were a fire in a plant.
Excellent. Thank you for that. And let's see. In a moment. Oh, here's another one that just popped in. Thank you to the audience. And here it is. How do I decide which gasket to use? And in parentheses, gaskets used elsewhere.
That's actually a very good question. When people ask us what gasket, we do ask a couple questions. We ask for their application. We ask what the media is, the product that it's going to be in contact with. We can maybe recommend something, but we always ask them to verify with their engineering and everything, as to make sure that it is compatible with their application. One of the things we do run into with gaskets, we do ask the question, are there other gaskets in that type of application where it's being used elsewhere in the unit? So if they have one that's a Teflon gasket being used over in this area, most likely it's going to be able to be used over where we're quoting a new unit. So that also helps alleviate what is needed there. And the other thing that is another thing that is sometimes often forgot. We ask for the pressure temperature, and at times people forget that there's also vacuum. And a lot of our gaskets are flat gaskets. So if you have full vacuum, which is hard to describe because everybody sort of has their own opinion of what is called full vacuum. If it's full vacuum, a lot of times we'll use like an O-ring or something that's a Viton O-ring where it cannot be sucked down into the process. So if you have full vacuum, we may want to change them over to something that would work a little bit better where we don't have to worry about it being sucked down into the process.
Very good. Thank you for that. And thank you to the audience member for sending that question. That was great. Okay, looks like we have one last question in the queue. So this more than likely is our last one, and here it is. Can you describe how the wiper systems work to address condensation on sight glasses? Are there any process conditions that would prevent the use of these systems?
Awesome. Okay. Yes, certainly our wiper systems, if you have condensation buildup on the interior of your vessel, basically there are two different types. One where the wiper is centralized in the sight glass, so the window has a hole in the center and a wiper assembly that fits into that hole with some O-rings and seals. Usually it's provided with a T-handle. It's also available with a ratchet handle if you need it out of the way on the outside where you're operating it, and you would just spin that to remove the condensation from the glass. If you have a high pressure application, as you can imagine, that glass with the central hole isn't going to be rated as high as a glass disc without a hole. We have another unit that actually is a type 2, and it goes through the weld pad and then has kind of a U-bar that goes up and wipes, and it has a ratchet handle to make that operate. A couple of process conditions that would prevent the use of either one of those would be full vacuum, because the wiper assemblies are not rated for full vacuum, so that could be an issue. And then also, I have come across an issue before where they had a higher pressure rating that they needed. However, the kind of U-shaped arm that operated the wiper on the Type 2 that allows for that higher rating was in the way of the spray balls that were being used to clean the interior of the vessel down. So there is some engineering and some work that needs to go into the wiper units. But they're a fantastic remedy for condensation, and we are always willing to look at any kind of special applications or requirements so that we can work together to come up with a solution.
I'll add
That's
one
great.
more comment on that, if you don't mind. You know, if our wipers possibly won't work for them, we also have a spray ring and also a spray nozzle option, which can also help clear. You can use water, you can use air to clear the window. All of those can possibly help as an alternative option to the wiper if needed.
Or in combination as well.
Excellent. Thank you both. And it looks like that was our last question, so we are going to move to wrap things up. So guys, thank you so much for that great presentation and also taking the time to answer some questions from the audience. We'd like to, of course, thank our audience. Oh, yeah, sure, absolutely. And I was just going to turn my attention and thank the audience. And thank you to the audience for those great questions and also sticking with us. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we'll talk with you soon.